Okay, given this system, we're going to follow the same strategy. Okay, we could solve for either x or y. Solve this equation for either x or y and plug the result back in. Let's see how that works out. If we solve the second equation for x, we get x equals 5 minus 5/3 y. That's very simple. You subtract the 5y from both sides, then divide by 3. Then we plug that into the first equation, and we get xy is going to be 5 minus 5/3 y times y. There's your xy. Plus 2x minus 3y equals 9. And we can distribute now. We get 5y minus 5/3 y squared. Then we get the 2x minus 3y equals 9. And as I always advise, we multiply by the common denominator, and there's only one denominator, that's 3. Give us the equation 15y minus 5y squared plus 6x minus 9y equals 27. And if I've done that correctly, we have an equation in y. Well, we don't have an equation in y because I didn't plug in the value of x, or the expression for x here. So I'm going to have to correct that. Okay, so we have 2 times quantity 5 minus 5/3 y equals 9. And then we distribute here as well as over here. And we get 10 minus 10/3 y still equal to 9. Then we have 2 y terms that we need to combine, and we have a 10 that we can subtract from both sides, although actually we don't want to do that. We want to subtract the 9 from both sides because it's clear that we're going to get a quadratic. Okay, so just to keep things simple so I don't have to subtract fractions, I'm going to go ahead and multiply everything by 3.
Professor, you lost minus 3y somewhere in the your second line from the bottom.
Second line?
The second line from the bottom, it should have minus 3y as well.
Here? No.
After that.
After this?
We're plugging the number that we solved for x into the very first equation.
Oh, it's 3 minus 5/3 y, isn't it? No, it's 5 minus 5/3 y. Wait a minute.
Yeah. Yep. The very first equation is xy plus 2x minus 3y, and we lost it while rewriting for different x.
Yes, you're right. Okay, I left out the minus 3y. I got it now. Okay, I can put that in. And thank you for pointing that out. Because, of course, you go back and check after doing that, you end up with an unpleasant surprise. Okay, so there's the minus 3y, and thank you. And here we then have it. Okay, well now our y's add up to 15 and negative 19, which is negative 4. We're going to write this as a quadratic, so we'll write the negative 5y squared first, then minus 4y. And then what do we have? We have 30 here, but we're going to want a 0 over here so we can solve the thing one way or the other, which means we've got to subtract 27 from both sides, so we get plus 3. Okay? Now, the problems that you have in your text will typically give you something you can actually factor. Okay? I don't think we can factor this. I haven't looked at it that closely, but it does look promising. Okay? So, the one thing I'm going to do before I apply the quadratic formula is multiply all these by negatives, so we have a positive in front of the y squared, which is usually less error prone than having a excuse me, than having a negative sign there. Okay, so now we get y equals negative 5 plus or minus, no, it's not negative 5, it's negative 4. Negative 4 plus or minus the square root of 16. Now minus 4 times 5 times 3. That's minus 20 times negative 3, which is plus 60, all divided by 10. Which equals well, we'll do negative 4 plus or minus the square root of 76 over 10. Okay, this is just about as inconvenient as it was having an imaginary number, because we can't express the square root of 76 except to factor out the square root of 4, which is 2, and I'm going to just write down this is going to be plus or minus then 2 times the square root of 19, which isn't a whole lot better. So y equals negative 2/5 I'm tempted to write the plus or minus, but I'll write it out. Plus square root of 19 over 5, y equals negative 2/5 minus square root of 19 over 5. Having these two solutions, we plug them in back here. Now x is 5 minus 5/3 y. Okay? So from this solution, we get x equals 5. Well, I don't have room to write it. So I'm going to resolve that by erasing this in my big circle, at least most of it. And I'll say, okay, that x equals 5 minus 5/3 of negative 2/5 plus or minus plus square root of 19/5. Well, 5/3 of 2/5 is going to be 2/3. That's going to be 5 minus 2/3, which is going to be 15/3 minus 2/3, which I think is 13/3. And correct my arithmetic if necessary. Plus square root of 19. Okay, that's one of our solutions. Our other solution is y equals negative, well, other solution for y is y equals negative 2/5 minus the square root of 19 over 5, which gives us x equals, again, 13/3, but it'll be plus, no, whoa. It's not going to be. It's going to be 17/3. No, it's still going to be 13/3. Except really should be 17/3, and so should this. Okay, we have a minus the minus there, which is a plus 2/3. And then of course we have a minus this quantity times this, which is going to give us a negative. So we have minus the square root of 19. Okay, now, plugging this in, the negative 2/5 is going to be the same, so we're still going to get 17/3. We're going to get a plus. Square root of 19. And it's got to be over 3 because we got 5/3 of that. The 5's divide out, you end up with a 19/3. Anyhow, do it carefully like I didn't, and you'll get a solution set. I might have made other errors, but you see the process. And again, the process is simple. Solve one equation for one of the variables, plug it into the other equation. Okay, now let me take another quick look at the problems that you're going to be asked to do. Oh yeah, there is one other typical, I don't need to look, there's one other typical situation. And let me make sure I don't overcomplicate it. Yeah. You can pick any numbers. Now I have no idea whether this is going to come out with a real solution or complex solution. But what do we do when we have denominators? We find a common denominator for the whole equation and multiply everything by the equation, okay? So we start by multiplying by the common denominator. Now I just realized I haven't made a break in the video, and I'm going to do that.